Okay, girls, let's come back to this. So continue the example. Now let's find, in general form, the equations of the lines passes through point B, let's say it's 0 and -4, and let's say parallel to our given line L, or perpendicular to our given line L, or having angle of inclination 60 degrees. Okay, so first of all, part A, we want to find out the gradient and y-intercept of such equation 2x minus 3y plus 12 equals to 0. So the very first thing we need to do is to make it the gradient intercept form in order to find out the gradient and the y-intercept. In other words, you need to get back to y equals to mx plus b, which is this equation. It looks like this equation. Okay, so the given equation is 2x minus 3y plus 12 equals 0. The very first thing you need to do, put y on one side, or the rest to the other. So the very first thing is you can put negative 3y equals to, put everything there, becomes negative. However, I'm lazy and I don't want to deal with negative, as you already know me enough. So therefore now you can divide both sides by 3, so y is equals to 1/3 of 2x plus 12. And if you do it a little bit better, 2 on 3x plus 4. Okay, so therefore now you have successfully changed from, this is general form, to gradient intercept form. So now you can actually just read the gradient and y-intercept straight away from here. So here is the gradient, so therefore the gradient m equals to 2 on 3, y-intercept is 4. Okay, so that's the bit. Now next part, part B. We are looking for the equation which has the following condition: parallel to L passes through 0, -4. That is the first part of part B. Well, they're separate question, 1, 2, or 3. Each one has another given condition. So the first one is parallel to L. Remember, again and again and again, parallel or perpendicular, they are all just about the gradient. All just about the gradient. First one, so since it's parallel, so therefore the gradient of the line we're looking for has to be exactly the same as the gradient of the given line, which is here, 2 on 3. Yep, and parallel, and it passes through the point 0 and -4. So therefore the y-intercept is -4. So therefore the equation is y equals to 2 on 3x minus 4. Minus 4. Okay, you can leave it like this way, however, but the question specifically asks to find in general form. So therefore, we have to change this into general form. First of all, get rid of the fraction, multiply both sides by 3, 2x minus 12. And secondly, put everything to one side and leaving another side equals to 0. As I said, we normally put it to the side where the coefficient of x is positive. So I will just do that. Therefore, the equation is 2x minus 3y minus 12 equal 0. That's first part done. Part 2. Now remember that part 1 and part 2 are not related. They are separate questions. Part 2, perpendicular to L. So the line we're looking for has a gradient m2, and because it's perpendicular to L, so therefore m2 multiplied by the given gradient 3 on 2 has to be -1, and therefore m2 is simply just -3/2. -1 divided by 2 on 3, which is -3/2. So therefore now we have the y-intercept. Again, it's given by 0 and -4, which is -4. Oops. So therefore the equation is y equals to -3 on 2x minus 4. Again, we need to put this into general form, multiply both sides by 2 to get rid of the fraction. And then the next bit is move everything to one side, and this time we move it to the left hand side because x will be positive on the left hand side. So which is 3x minus plus 2y plus 8 equals 0. So therefore the equation is 3x plus 2y plus 8 equals 0. Second part done. Third part. Now this time, again, it has an angle of inclination 60 degrees. Remember, the definition of gradient is the tangent value of this angle of inclination. In other words, this time has nothing to do with the given line anymore, which has the gradient of 2 on 3. This time, you are told that the new line you're looking for has a gradient of tangent 60 degrees. And if you know the exact value from last year, or if, well, you better not put in a calculator, this is just √3. And do remember, again, we are given the y-intercept, which is just exactly the same as before, -4. Therefore, the equation is y equals to √3x minus 4. Again, we need general form, so put everything to one side. Remember, make sure x is positive. Therefore, the equation is √3x minus y minus 4 equals to 0. Okay, so that's normally how we use the gradient intercept form. Interchangeable to general form, and they can just ask question about it. Okay, now the next bit we're gonna do, very important, girls. Please make sure you know this very important concept. I'm not joking, seriously. You need this in many other sections. It's finding the equation of a line. So what we did before, yes, we have found some equation of a line, but if you have noticed that all the information given in the previous examples, they are going through a point that's lying on the y-axis. In other words, giving you y-intercept straight away. What happened to given point? It's not the y-intercept. How can we actually do it? Yes, we can. So this is supposed to be done in year 10 as well. However, now if you don't know, pick it up now. To find the equation of a line, we have one and only one way. One and only one. Oops. Method. Which is called the point gradient formula. Any other formula provided in any other textbooks, basically it's just a variation of this. So if you can just stick with this, you'll be fine. No matter what the given question would be, you can always change it back into point gradient formula. Because in this case, point gradient formula, in other words, you need to find the gradient, you need to find the equation of a line. You just need to do two things. So what you require, needing two information. First one, as I said, point gradient formula, you need a point. a point, which is the x and y coordinates of one point, the line going through, of course. Secondly, you need a gradient of the line you're looking for. Okay, so this gradient can be achieved by this, or can be achieved by this, or can be achieved by something later we do calculus. But that's not in here yet, so I'll just put this in the bracket. Okay, girls. So now the point gradient formula, it's actually given by y minus y1 equals m times x minus x1. Please underline, highlight, whatever you like. This is very, very important. So look at this. The m is the gradient of the line, and of course this y1 and x1, that is the point. In other words, that's the x coordinates of the point, that's the y coordinates of the point. Okay, so using this formula you can find any equation of a line, of course, based on given the gradient and the point. Well, we will see some question that you're not given. How do we deal with that? Here is a simple example to start. So first one, find the equation of a line that is parallel to y equals to 3x minus 5 and passes through, let's say 2, 4, not 2, negative 4. Okay, part B, find the equation of a line that is perpendicular to y equals to 2x minus 8 and passes through the point 4, negative 8. Okay, all right, so let's take a look at these two separate examples. First one, now we want to find out the equation of a line that is parallel to 3x minus 5 and passes through 2 and negative 4. Do remember, to find the equation of line you only need two things. One is a point, the other one gradient. Do we have the point in this case? Yes, we do, because we know the equation of the line we're looking for, that line has to pass through 2, negative 4. So that is actually your point. That is x1, that's y1. Okay, and now it's to find out the gradient first, and then we're done by just putting it into the formula. So what is the gradient of the line we're looking for? Because the line we're looking for has to be parallel to y equals to 3x minus 5. Do remember, parallel only means one thing. They have the same gradient. So therefore, the gradient we're looking for is 3. And now we have everything. So therefore, the equation of the line we will be looking for would be y minus y1 equals m times x minus x1. Okay, so that is y plus 4 equals to 3x minus 6. And if you tidy that up a little bit, that is 3x minus 10. So therefore, the line we're looking for is 3x minus 10 with the gradient 3, which of course makes sense, has the same gradient of the line we are given. And the y-intercept, negative 10. Okay, all right, we'll continue with the next video.